committee. But today we're going to be talking about how do we adapt cybersecurity strategies for blockchain technology. And we're starting this kind of based on an article that one of our committee members, Dirk, wrote. So we're going to start with him. But first, I'm Jessica Levesque. I'm C4's Executive Director. Thank you for joining us today. And Dirk, why don't you get us started with introducing yourself, and yeah, we'll work our way around.
Yeah, I'm Dirk, and like Jessica said, I'm one of the committee members here and have been for a while. I'm also the chair of the Certified Bitcoin Professionals Committee. Yeah, this whole thing kind of stemmed from an article that Jess mentioned that I wrote that actually came out of a conversation with another security expert who is not in the blockchain world, and we were chatting over beers one time. And I guess, I mean, I hate to use this word because people always cringe a little bit when you talk about a paradigm shift, but blockchain brought with it kind of a paradigm shift to technology, and we see that in a lot of ways. But one of the ways I think hadn't really been, kind of discussed was some of the impacts to security. Those of us working in the field have kind of just adapted, but we haven't necessarily really talked about them in the past outside of key management primarily. So I thought, it was an interesting topic to dive into. And with the people on this call who are way smarter than I am, it should be a good conversation.
Awesome. So yeah, let's just go around and intro ourselves, and then we'll get more into the topic. So Mark, do you want to go next?
My name's Mark Christianis. I'm a committee member, and I'm also a CCSS auditor. And I audited Fireblocks and Liminal, who are the first two entities in the world that have their systems certified.
Awesome. Thank you. All right, Josh.
Hey, Josh McDougall, one of the founding members of C4 and one of the original co-authors of the CCSS. It was pretty obvious that it was needed when we realized that most security teams don't have to deal with the fact that undo doesn't exist in their world, and it certainly does in ours.
Awesome. Michael?
Hi, I'm Michael Perkland. I'm the chairman of the board of C4 and one of its original founders. I also have the honor of working alongside Josh in creating the first draft of the CCSS that has evolved quite a lot over the last 10 years, thanks to the help of these fine, I was going to say gentlemen, but there's also a lady here on the CCSS steering committee. I love security, I love technology, and I love finding new ways to break things. And that gives me a keen insight on how to secure things as well. And it's a pleasure to be here.
That was a perfect segue into Ron talking about breaking things and securing things as well, because I know that's what you love too, Ron.
Yes, thank you. I'm Ron Stoner, a hacker and security researcher. I've been a committee member for years, working with everybody here on the call. Very much enjoyed that experience. The first CCSSA and architected the first iteration of the exam. It's really grown and evolved since then, and really excited to see what we've been doing in that time.
And taught the first course on it.
That's true. So Dirk, do you want to get us started? I know you gave a little bit of an intro, but we've based this live stream off of an article that you, Dirk, wrote, and I'm going to paste the link to it in the chat so that anybody who is interested in reading it after can take a look. But why don't you maybe explain why you wanted to write about this in the first place? You gave a little bit of a hint into it, but like, what is the significance of talking about this, and how some of these policies changed over the years with blockchain technology?
Yeah, sure. And like I said, it came out of kind of an over beers conversation with another associate of mine, and what really kind of came to light there, right, was some fairly fundamental perspective shifts, right? It's not necessarily that nothing in traditional security applies, but there are some perspective shifts that we have to make in how we look at it and how we apply the tools of traditional security in the blockchain space, because like Josh said, right, there's no undo in blockchain, right? Crypto moves, it's moved, it's gone. And that's one aspect, right? So that kind of changes the overall perspective that we have to look at this from one of, from one where a lot of emphasis gets put on incident response and incident response testing and that sort of thing, to one where you really have to focus on don't let the bad thing happen in the first place, right? Because if it does, you're probably just done. Um, so that kind of led us down this rabbit hole and led me down this rabbit hole of thinking about other ways that that the technology kind of shifts some of the ways that we look at how we apply information security in the industry.
Yeah, and I think one of the things that you brought up too is that there's constantly some sort of new attack vector happening. And so we always need to be keeping up with what is kind of new and what's going on. I don't know if anyone else has anything they want to add to that point before we talk a little bit about traditional security models.
Yeah, no, absolutely. And I think that is true across traditional, right, as well, right? There's always new attack vectors. But what we changed with blockchain is not just the attack surface or the attack vectors, but kind of what you're attacking and how you do it and some of the things that impact that.
Yeah, and Michael, I'm going to call on you for this because you're the first person who taught me about the CIA. And if you're from the United States, you might think we're talking about the CIA agency, but we're not. This is actually pretty cool, though. So do you want to walk us through the triad?
Sure. So in information sciences, which is sort of the underpinning of security, one of the axioms that is often used in that industry is the CIA triangle. If you imagine a triangle and each of the 3 points has a C, an I, and an A, it stands for confidentiality, integrity, and availability. These 3 points can never be maximized together, because if you maximize confidentiality of data, then you naturally are minimizing one or both of the other. The easiest way to imagine this is to think of some kind of a secret. Let's say the Colonel Sanders recipe for his KFC. If you want to maximize confidentiality of that recipe, you can have only one copy buried in a mountain with bunkers and guards and everything. And sure, now that is the most confidential secret ever, but it is not available. If you want to read that recipe, you have to go through a whole lot of steps just to get at it. And it doesn't really have a lot of integrity either, because if that mountain blows up somehow, that one copy of the data is now gone forever. You can increase the integrity by having multiple copies of it. That also makes it a little bit more available, because now you can access it over here or you can access it over there. But naturally, it is now less confidential. So with all security systems, there's an interplay between these 3 points on a triangle: confidentiality, integrity, and availability. And that underpins a lot of classical cybersecurity practices. But it also informs us when it comes to blockchain security as well, because we draw on the same information theory regardless of what it is we're securing. The biggest difference is the value of that information. With traditional cybersecurity, you may be safeguarding patient records in the healthcare industry, or employee or customer records, or some kind of information that, while it is valuable, it is not value itself. With cryptocurrencies, when you are safeguarding information, when you're safeguarding these private keys have a direct monetary value, an immediate monetary value that is available to everybody, rather than only available to the few people who are looking for a list of credit card numbers, or the few people looking for Colonel Sanders's recipe for chicken. So the stakes in a blockchain world are a lot higher, because the information is directly valuable, than with the traditional cybersecurity world, where that information may not be directly valuable.
That was a really good explanation of it. And since we all are going to continue watching this stream rather than going out and grabbing some fried chicken, maybe we should move into talking a little bit about how we need to prevent attacks from happening rather than just responding to them. And Mark, do you want to jump in and explain a little bit about what prevention over response looks like?
Absolutely. The information security or cybersecurity principles from, shall we say, the Web 2 space or the legacy space still is quite applicable to the blockchain space. As we know, blockchain is based on cryptography and proper sound key management, and those practices and principles have been with us for decades now. The interesting thing, though, is, as Michael talked about, is that there's a direct impact if you lose your private keys. And some of the vulnerabilities or threats in the blockchain space are quite unique. We've got things such as vulnerabilities in the smart contracts, particular the way that the smart contracts are created. There's particular vulnerabilities that are not known in the shall I say, the legacy world. There's access controls related to signing keys, weak encryption. I mean, some of these things are already, we know about quite a bit. Not monitoring your wallet addresses for suspicious activity, quantum computing that's coming up in terms of breaking current encryption algorithms. So there's a lot of things that we need to look at controls to prevent attacks and actually detect them before they occur. And so I think a lot of the blockchain space will be covering preventative controls a bit more than just the reactive controls. For example, just monitoring the wallet addresses for suspicious activity.
Yeah, and I think let's go through some of the examples that you gave in a little bit more detail. Maybe we can talk a little bit about some of these threats in particular. And I know we want to talk about smart contracts. Should we talk about the threats now? Does that make sense to jump into this a little bit? What do you guys think? Josh,
Yeah.
Ron? Yeah, okay. Let's get into some of the smart contract vulnerabilities.
Sure, I can jump in.
Ron, why don't you start us off?
Sorry, go ahead. Thank you. So yeah, if you're taking traditional security concepts and kind of airlifting them into this industry, you will be somewhat effective, but you're going to fail, because what I like to say is, there's no re-entrancy attacks in traditional corporate security. There's attacks very similar, but when we talk about re-entrancy attacks, we're very specifically talking about smart contracts and the functions that they're calling. And if you don't have awareness of that, or you're coming in with just kind of a base level of knowledge, you're not going to understand how that works, how that can affect your product, and how, ultimately that could tank your company, your reputation, and your treasury. So when we're looking at smart contracts, it's things like reentrancy attacks, but it goes a little bit further to where you want to consider other options like, who is the actual ultimate owner of the contract? What address owns that? How are those keys generated and being stored and transferred? And, we've seen in this industry where developers are the ones that have the final say on the contract. And that's very similar to giving your developer root access to all of the systems in your company, right? They have the ultimate control and ownership. And we've seen types of attacks where those devs have either, maliciously used elevated functions, they perform griefing attacks, or even held the company ransom, right? So it's very interesting because these are some different types of challenges that we have to approach and tackle, secure, and then advise on, right?
That's a great point, Ron. In addition to that, another big difference between the Web3 world versus the Web2 world is the code that is running on servers. In a Web2 world, chances are most of the code that you are running is closed source, or even if it does use open source components, the exact configuration of the server will differ depending on how an administrator is implementing it, and that makes it harder for adversaries because they don't know exactly what they are attacking. By contrast, in the Web3 world, when you deploy your smart contract, not only is the bytecode available for all computer scientists to decompile and try to recreate the original source code, but chances are, in 99% of the cases, the full unadulterated source code is available on GitHub as well. This means that your adversaries are immediately armed with everything that your system is doing, So they don't have to breach first and look around. They can just go to where you've published it and find issues that you may not have seen. This raises the bar dramatically for anybody who's deploying code in a Web3 world.
And
Yeah,
the,
oh, sorry, go ahead, Josh.
The, at a very, very basic thing that you learn quickly as well in this space, when deploying a smart contract, unless you build this functionality into it, it's out there and it's done.
Yeah.
So it's something that you generally have to get right. Or if you do build these mechanisms where you can update it or evolve that exact thing, then as Ron was alluding to, you have to make sure you could control those keys very securely using something like the CCSS to make sure that those keys are generated safely, held safely until they're necessary. Who has access to those? If those have administrative privileges over this, decentralized contract, that's a very, very important thing. If you don't build these mechanisms in, if you don't build upgrade paths in, or even kill switches in, then there's nothing you can do about it. You can tell people to stop using it, but if it's working in some sort of malicious or unexpected manner, there's nothing you can do if you haven't built that in. So when we say there's no undo, we really have to be careful that what we're deploying into this space has enough eyes on it, has enough careful attitude put into it that we're not in a way acting unethically by just releasing some tool into the world that is going to exist in this space for as long as we can handle it. It becomes even more difficult down the road. We discussed reentrancy. Reentrancy is kind of like how the contract interacts with itself, which is fascinating. You don't really think, okay, well, what about when this software starts to use itself? You don't really consider that aspect a lot of the times. But then there's also, take something like Ethereum. There's thousands upon thousands of smart contracts out there. How do each of them interact with each other starts to become very fascinating as well, and something that requires careful modeling, or it will result, and we've seen it time and time again, in unexpected behavior and likely a loss of funds.
I suppose that also comes back to making sure that your developers, your developers, you've vetted them, you've done the background checks, because they have so much power. And also ensuring that the developers are actually trained in how to code securely, so they don't actually introduce some pretty easy or rudimentary vulnerabilities. And I think it really does come back to ensuring that the developers are well known, vetted, and also they know how to code securely.
Yeah, because I think the thing that's been touched on here is really important, right? And this goes back to the basic principle of prevention is, like Josh said, if you don't build into your smart contract the ability to change it once it's on the change or on the blockchain in some way, right? Once it's been published out there, that doesn't exist inherently, right? And it's going to just continue to operate as it was programmed to operate. And if somebody figures out, they look at the code and they figure out some clever way, whatever that is, to abuse it, and it has access to wallets and controls assets, right? It's going to keep doing that, and you can't stop it unless you've actually built those things in. So it's not just a matter in the traditional world. You roll out a web application, and maybe you're like, okay, well, we can fix some things on that, right? We can add a little bit of code here, add a little bit of code there, and we can tweak it and we can fix it. And if somebody, comes to us and says, hey, I found a bug in your application or whatever, you fix it. You can't do that. It's too late by the time that you figure most of that stuff out, generally speaking, right? And if, whatever it was controlling, you no longer control.
Yeah. And I think this is not new to cybersecurity. I think it's, as far as fields go, it's something that requires constant learning, constant paying attention, and openness to new technology. That's why all six of us are sitting here today, is because there's an openness to new technology that came in and said, okay, we've got to figure this out. Developers in the space, especially when it comes to smart contracts, really need to be following that too. And because that landscape is very frequently changing, and usually for the better. Originally, something as simple as integer overflows, where if I decrement my account enough, I might roll over, and now I've got some trillion billion tokens or whatever, because the integer has overflowed to the large positive version of it. Excellent, great for me. That wasn't built in to the Solidity language at first to check for that kind of thing. And then there's some libraries got built, and then now that's evolved into some better technology in the language. So we're learning from our own mistakes. But if you don't know that these things have been dealt with and improved, you might still use old technology that's not necessarily the smartest thing to do. So staying up on what you're doing, as silly as that sounds, is a very important thing, is certainly one of the similarities between the classic tech industry and our industry. But I think it's like, because of the sensitivity, such a more critical aspect.
Josh, you just
technology is developing so quickly that we need to keep up with it. And you can probably talk more about that, Ron, and how you are, there are constantly new vulnerabilities and risks coming in.
Yeah, I was going to add, Josh touched on one I had on my list with the integer overflow and underflow. These are new technologies, using new paradigms, new systems, new libraries. In some cases, we're seeing a lot of old tricks that are being applied to the new system, right? So even with integers, if you just write a smart contract and you write all your own math operations, you're probably going to have a bad time. You're going to lose funds. There's safe math approved libraries. There's things that are out there that are setting correct max min bounds on some of these variables and integers to ensure that you can't use some of the old tricks that people used to use in systems on some of these newer technologies. So it's twofold. You have to have awareness of basic security and old attacks, and then how do they apply with the new technology plus the new attacks. One example, one of the most novel, mind-blowing hacks I've ever seen, very simple. Somebody went to withdraw Bitcoin and said -10, and the system accepted it and gave them 10 Bitcoin. So when you think about that and how that's architected, the dev that created it, the product that created it, didn't have that foresight or understanding of knowledge to protect against that type of attack. Very simple, but very effective.
I think that's a really important point to make too there, Ron, because it's kind of a two-way thing. We're not just saying that people from traditional security coming into the blockchain world have to learn something. There's a lot that goes on in the blockchain world too, right? A lot of people who just embraced blockchain and Bitcoin and crypto early on didn't come out of traditional technology and traditional information security backgrounds, right? And they kind of look at it from the standpoint of, hey, that's already taken care of, right? The blockchain and it's a cryptographic system. It takes care of this, right? As long as I keep my private key private, everything else is taken care of for me, right? And so there's kind of a gap sometimes there as well, where people start developing something like a smart contract that haven't been through secure coding practices and training and that sort of thing in the past, and then they write something that, like Josh said, can do whatever it's going to do, and it's out there for good.
So many people were so excited about this technology, especially smart contracts, when it launched. But like when Ethereum launched, so many websites popped up about, okay, learn how to program with smart contracts. And in a way, that was like saying, like, let's learn how to cook with fire breathing. Like it was like let's give you the most difficult paradigm that's ever existed, and like give it your first hello world. And these people still got excited and still learned, and some of them probably went in to do amazing things, but like it didn't necessarily set us up for success as far as security goes. So now, not to say things have calmed down in any way, but I think there's a little bit more maturity to the space, certainly on tooling, certainly on best practices. And I hope those people who learned programming through Solidity are still with us.
Derek, you touched on one thing very fleetingly, but I think it's good to shine a light on it. The loss of a signing key. That's another really different paradigm in the Web3 world versus the Web2 world. In the Web2 world, if you lose your credential, you can do a password reset. You can ask an administrator to change your password, something like this. In a Web3 world, that does not exist. If your private key gets compromised and somebody else learns what it is, you can't just do a key reset. What you could do, you could transfer your assets to another key, but you can only do that before the compromise, because once it's compromised, that's exactly what the attacker is going to be doing to you. So this puts a lot of onus on the people using the system to use it in a secure manner every single time, right from the start, without any fail. There isn't really a lot of room for making mistakes as you go and learning and picking it up, because one wrong mistake could mean the loss of your funds. And that's a very different thing for security professionals to wrap their head around when coming to the Web3 world from the Web2 world.
Yeah, I agree with that, because a lot of the users that were new to crypto came in looking at DeFi and so forth, just like they would think of as a bank. So if you lose your password in your bank account, yes, you can reset your password. But as you just mentioned, you can't reset your private key. And I think a lot of things about security in the Web3 space is about trying to reduce the complexity, because I think complexity in this space does also cause security issues. And for example, someone comes in and tries to install MetaMask on their web browser that's never been in crypto before. I mean, just that task alone is quite complex for someone who's never done crypto before. And all the messages that come up when you do transactions, I would probably believe a lot of the people that are not new, that are new to crypto, would just start hitting the OK button on all these messages that are coming up, because you got these long wallet addresses, you got all this gobbledygook, and they just keep hitting OK. And I think that definitely brings in risk. And I know there are attack vectors where they take account of the fact that most users will just click the OK button on some of these messages and not actually realize what they're granting in terms of permissions or what's happening in the transaction.
I mean, on a personal level, that's scary. Think about that from an enterprise perspective, though. Think about how many people in enterprises around the world have MetaMask with a random wallet sitting on their work computer, on their in their work browser. There's whether or not those assets are controlled by the company, which is now, the finance department doesn't have insight into these assets, and that's its whole other problem, or their personal assets. And now the company is at risk if they ever wipe that machine or something. The employee is going to be like, "What did you do? My Bitcoin or my Ether?" And the company's going to be like, "What are you talking about?" So just by being unsure and unaware of these assets that are potentially sitting across an enterprise, there's a whole new risk that they already had to deal with. I saved my kids' pictures to the company laptop and those are gone. Now it's, I saved my life savings to the company laptop and those are gone. Those are both potentially really big problems. Or, hey, I had some of the company's assets and they're gone because I didn't keep them.
Yeah, and I think we've talked a little bit here now about actually having access to signing keys. There's a couple different things related to signing keys in terms of making sure that we keep track of them. We don't transmit them, give them to others to also have the same keys. But maybe we can talk a little bit about encryption protocols in terms of actually generating these keys and what's happening. For those of us who are not super technical like me, I wouldn't know before I got into this space. If someone had talked about the entropy in terms of a private key, I would have been like, what? I'm supposed to look for what? So if you're not a security professional, how do you know who and what to trust? You might just hope that the people you're trusting are doing the right thing. They might not be. But what do we mean by weak encryption or strong encryption?
Yeah, I can jump in here. This is really the foundational level, right? So you can have and it doesn't exist, but I'll say you can have a 100% secure front end and back end and product that your customers interface with and still get hacked and lose all your funds. And the way that happens is by either your keys or your seed phrases being compromised. So We're talking about, cryptography here with doing seed generation. That's really the first step and the first foundational level on this journey. You want to think about how you're securely generating your seeds and keys. And that really ensures the uniqueness and unpredictability of the cryptographic keys themselves. That can get very deep with technical considerations like, are you using guessable nonce values? What are your K values in your encryption schemes? Which ciphers and algorithms are you using? And thankfully, guidance like the CCSS helps provide some information on that for users that are looking to understand, well, what did we use and was it secure? And, this is an involved process because sometimes it goes as deep as looking at the source code itself, doing an evaluation and an audit to understand what is this actually doing with the math and the information here. So if you can securely generate your seeds and your keys, the next step is, where do you store them and how do you store them securely? And that's where the encryption kind of piece comes into play. And it's all very much so the same considerations. What algorithms are we using? What's the cipher strength or the bit key length on some of these pieces? Are they secure enough or is it guessable? If I generate 3 of my own secrets, can I compare them to my encrypted secret and derive the value? So you want to start to walk that path to understand. And then once you have it kind of securely stored, your data at rest, you need to transmit that to somebody or some system to use and either decrypt or transmit it in a way that it has access to it, that it can do the thing it needs to do with the key or the seed phrase. So now we're in transit, right? We're kind of walking the whole step of, we've got these things generated securely, we've got them stored securely. Now we need to transmit them securely and ensure the people that have access to them are going to continue to be the people that need to have access to them. And it really branches off into your onboarding and your offboard policies, your key rotation policies, as well as your key compromise policy.
And all of these things exist in the traditional world, fundamentally around protecting credit card data, right? And transaction data to websites. And I mean, again, these aren't necessarily new technologies specifically, but it's the emphasis on them, right? Because again, if you lose access to your private key, you've lost access to your funds forever and done, right? If somebody else compromises your key, then your assets are gone, and there's no interbanking rules to request that they be transferred back from wherever they went or anything like that, right? They're just gone. It's like somebody stole cash, right? Somebody takes a great big wad of cash out of your house, and unless you can figure out who it is, it's just gone, right? One of my favorite stories, kind of to illustrate what you were talking about, Ron, Josh told me this years ago, about, I think it was a Bitcoin wallet on Android where they were using really poor entropy. And so you would generate a wallet on your Android phone and there'd already be money sitting in it because it had actually generated a wallet that it had already generated and somebody else was using, because the entropy being used to generate the keys for the wallet. And sadly, I've never yet generated a wallet and found that there was just already Bitcoin sitting in it for me. So
One day.
Yeah. I think if you bring it back to an enterprise level too, is having a key inventory. So at least you know where your keys are, where your private keys are, who has access to them, are they being backed up, where are the backups, the rotation periods, if you need to rotate, that type of thing's pretty important, because you hear stories of organizations that created a cold wallet years and years ago, and they thought they're going to be really good, and they'd hide the C phrase or some of the other bits and pieces of it, and they'd hide them somewhere so no one would find them. But then unfortunately those people left the organization, and then new people came in, and there was no documented documentation in terms of where the C phrase is actually located, and they can't do anything with the wallet.
Yeah, and so we've probably scared anyone who's listening or watching to death. So, but what we want to focus on now that we've identified that there are a lot of different challenges, threats, risks that are taken when you are participating in cryptocurrency or digital assets, there's also a lot of ways to mitigate these risks. And so that is why we at C4 have the CCSS, the Cryptocurrency Security Standard, because we believe that if there are hackers out there trying to do bad things, well, we can do what we can to prevent them using strategic, intelligently designed controls that are battle tested, that have a lot of history behind them to make sure that we're using it in a way, using crypto and private keys in a way that are safe. So let's talk a little bit about how we can implement these effective controls, and we'll talk about monitoring, and maybe we can do a little bit with preemptive controls, and how do we authorize access, and what does this look like? And let's point out a little bit of the standard as we go through this as well.
Well, I think the first thing is you just like in the old legacy world is you have to work out who wants to do you harm in the first place. So if you work out and you identify the things that could do you harm, then you work out what the attack vectors could be. So how could someone get in and do you harm? And then from there, you'd be able to say, well, okay, so if the attack vector is someone who works for me or a developer can go rogue and have access to the signing keys, then how am I going to stop that? And then from there, you naturally progress down, and using CCSS, you can work out, well, you need to ensure that the people that have access to the signing keys really need that access for their role, and you just don't leave the keys accessible to anyone. And FTX was a classic example. When they first released the first interim report, one of the things that they found was that some of the private keys and seed phrases to wallets that contain billions of funds, billions of dollars worth of funds, they were actually just left on file servers unencrypted, and there was no access controls on who could access the file server. And it was just a matter of time before either they got caught out with fraud or what have you, but ultimately they were coming up for a major hack at some stage because they didn't protect the keys at risk. So I think access control is pretty fundamental. Who has access to the keys, and make sure that there's actually more than one person who has access to the keys. Because if the keys are protected by, say, the CEO and only the CEO, well, if the CEO gets run over by a bus, what are you going to do about it?
Yeah,
The CEO is generally a horrible person to have access to the keys.
But it happens. It happens.
You have to. That's a really good point, though, that the organization has to want to do this. This has to be like a systemic belief in the enterprise that protecting this is important. Now, obviously, FTX didn't think a lot was important, so that's a whole other story. But if you're not running a horribly fraudulent organization, then protecting these assets, protecting your customer assets, because that's what these were, customer assets. Protecting the assets of your customers should be the number one priority. And from there, if you as coworkers believe that, starting to put these policies into place, and when you see something like that going, this isn't right, because obviously that's not right. I don't think you even need to be a computer scientist to go, that doesn't sound correct. But here we are.
Right.
Well,
Well,
I think you touched on. Oh, sorry. Go ahead, Jess.
I was just going to say the standard that we have to use actually outlines these things for us. And as you guys are talking, I'm looking at the standard and refreshing my memory, and it's like ding, 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 ding. It's all in there. So we talk about how keys are being used. That's 1.04. We talk about how keys are being stored, 1.03. It's all in there. And for anyone who's watching the standard, I put a link to it. You can read it yourself and check out how these all tie in. But from my perspective, it's fun to really see how all the examples of threats, I'm like, oh, that's covered here. Okay, that's where this came from. And we can really map this out to see how and why people are adopting this standard. And go ahead, Dirk.
Yeah, I was just say there's something that Mark mentioned, touched on that I think is really important to call out too, right? And that is that there may be some shifts in perspective in how we have to, apply controls, how we have to look at the importance of certain kinds of controls versus other kinds of controls. What has not changed, and I know this is a big thing to Mark actually, is the methodology of risk assessment and risk evaluation, right? That fundamentally stays the same, right? What we're talking about doing is literally risk assessing a new technological environment, right? And looking at what are the threats and what are the threat vectors, and then what are the possible controls to mitigate those, and how do we apply those, and how do we measure them? And so that process, right, hasn't changed across information security. It's the specific like security controls and prioritization of controls and how we need to approach things that has kind of shifted. So. And we could talk about keys all day long, this being the CCSS committee and all, but there were a couple of other areas that I think are really interesting to touch on in blockchain that are different. And one of those that I think is really kind of interesting is the consensus mechanism, right? The fact that the fundamental security of the entire thing is built around cryptography, yes, right? It's the cryptographic, those are the tools. But this concept of a consensus mechanism and the game theory that comes into play in blockchain as well to make sure that everybody's playing by the rules, right? That somebody doesn't just say, "Hey, I'm going to run off with all those wallets instead of or all that Bitcoin instead of like going ahead and mapping it out, right? Or mining it properly." And so I think that's really interesting. And something that people, again, just getting into it, don't necessarily spend a lot of time thinking about. There was a case with a network called the Ronin network that had too few of validators on their network, right? And required a certain percentage of them to validate, and a couple of them were outsourced and weren't properly being the security on those, the traditional security on those devices wasn't being properly managed, and it allowed somebody to, in theory, walk away with like $620 million, even though it wasn't really because you couldn't really do anything with those tokens. Um, uh, but just this idea that that the security relies on the network, and I'll shut up there and let somebody else talk.
No, that was consensus is fascinating because it's also a big part of why we're here when it comes to this technology. That's the whole thing that it got solved. But it's not always perfect, and there's just fascinating things that can come of it. That's a huge issue where like, oh, the network's value could go away. There's much smaller things that we have to worry about every day though too. Just, oh, I sent a transaction. Did it go through? It looks like it's going to go through, and then it didn't. So building systems that can detect when something didn't happen is critical. There are many cases in which someone developed a system where the user sends their service some, let's say, Bitcoin. They increment the internal database ledger to say, yep, this user sent us some Bitcoin, and then something happens to the transaction and it doesn't actually go through. Now my database is inconsistent with the reality of the network. If I don't know to build that in, then that becomes a very, very big problem very, very fast. And we've seen, this is a very small example. We've seen extremely bad cases happen to very large reputable names who just got confident thinking that the network was going to perform a certain way, and it didn't. So understanding how these things happen, monitoring for network health, it's an extra cost, but at least knowing when things are inconsistent in that world and shutting down internal systems until you can understand why.
The consensus layer is also important because, as Dirk was saying, it's the kind of security control with how the network's moving forward. And it's interesting because you can get to the end result in a lot of different ways, right? Some people might be Rust fans. They want to use Rust-based clients for all of their stuff. Some people may want to use Go, and they're using different libraries or methodologies. But at the end, when you're writing to a chain or you're pushing transactions, it needs to be a certain way, or it will be rejected by the consensus mechanism and or the community. And what that really ensures is that, I can't write malicious client to go, achieve consensus on a chain and rewrite the state or rewrite my transactions. So it's interesting because there's many different ways to get to that final result, and consensus is what really kind of brings us together.
Yeah, exactly. And I think I just find it to be a fascinating topic. And it's one of those, it feels like it's just a big topic, right? But it actually, like to what Josh was saying, right? You need to be monitoring, especially if you're dealing with smaller chains, right? Fundamentally, with meme coins that aren't necessarily sitting on top of Ethereum or something like that, right? If you're dealing with cryptocurrencies, you have to be monitoring that. We don't sit around monitoring the health of the internet in order to be able to run e-commerce sites, right? But you literally have to do that if you're going to really be doing any sort of serious business, on a blockchain network. You have to have an idea how that looks like. Does China all of a sudden have 60% of the processing power? I mean, these are questions that you have to be thinking about yourself just as a user in order to ensure the security of your assets.
Mm.
That reminds me of another pretty big difference between, well, I guess it wouldn't be a difference so much as it's a difference today between the Web 2 world and the Web 3 world. Today, most people know how websites and web applications work. People have gotten used to, creating secure passwords. They know the basics, like not to use their pet's name or their birthday. They know that when they're accessing a website, they should take a look at the URL and am I really at that company's website, or is an I replaced with a 1 or something like that? Domain squatting. People have had the
on, right?
Exactly, yeah. We've had the benefit of working with web applications for the last 30 years. Many of us grew up with it, so we know how these work. Now we're in the cryptocurrency world, the blockchain world, where instead of dealing with passwords, we're dealing with private keys. Instead of dealing with a company that services your requests, you're dealing with a decentralized blockchain that services your requests. And the paradigm is considerably different. A lot of the users who are now going to be interacting with your system, whatever system it is that you are building, they're not going to be as familiar with your system as the average computer user is going to be with the average web application. That means that naturally, with every smart contract you develop or every system that you are going to be running, you also have to sort of run your own support system where now you're teaching people, I hate to use the word basic cryptocurrency skills or basic blockchain skills, but the reality is, because this is so new, it is going to be so much more difficult for your average user to deal with your new system than with a traditional Web 2 based one. And I love to see in our industry so many of these projects that are building crazy things. They have very clear wikis or FAQs or video walkthroughs. There are so many influencers talking about these things and making their own videos on how to use this thing, how to do that thing, that it really does feel like we're all sort of lifting each other up together. And without that kind of education for these new things, I doubt we would see anywhere near as much adoption of this technology as we do today.
Yeah, I think it comes back to also is trying to reduce the complexity, because as you mentioned, the e-commerce has been around for decades now, and it's very easy to do. It's very simple and everyone understands it. But as I mentioned before, when you're trying to install MetaMask, most people aren't going to try and install MetaMask and understand what that's doing. And definitely the complexity. And I think another thing that's important too is there's less scope to introduce security controls into a platform when it's up and running, and then instead of actually thinking about security when you're designing the platform. So in the e-commerce world, most of the time you built an e-commerce site, you maybe put in some rudimentary security controls with the expectation that once you have enough money, you'd have a proper security program and you'd fortify it. But, as it's mentioned before, smart contracts, once it's online, most of the time you can't retrospectively apply security. So I think with the Web3 space, putting in security or thinking about security at the architecture and design stage is more critical than the Web 2 space. It's less forgiving in Web 3.
Yeah, it's definitely not something you want to sprinkle on at the end. That is not effective. And the CCSS, although we've talked about it as an assessment and an audit tool, the CCSS is a great document to help guide you as you're designing your architecture as well. There's no reason why it's an open source document. There's no reason why you can't have that open and understanding, okay, you know what, at some point we're going to have to deploy this smart contract. Let's discuss today how our key system will work, who will, hold this, who will actually do the push to that production environment. Or, you know what, we're designing a system that needs to handle refunds. What's refunds going to look like? Who will have access? How will funds move in and out of that refund system? These are all questions that should be being asked in that architecture and can easily be referenced with the CCSS. The CCSS is designed specifically with all of these hacks that have come into play, looking at them going, how did that happen? How can we prevent that? And these are the lessons that we hope are available to new people to not get hit with the exact same thing that we already know how to solve.
Yeah, and we started talking about fried chicken, so I'm going to take this to another food angle. So if we're thinking about security, and to reference what you just said, Josh, with sprinkles, we've got a bowl of ice cream. We're not just throwing sprinkles on top. We're talking about the base, the cone or the bowl that's holding the ice cream, rather than just dropping a few things afterwards. And the question really is, how strong is the cone or bowl that you're eating ice cream out of? Do you know whether or not it's going to actually be supporting this ice cream? Clearly, I really like food, so that might be where this is going. But I do think that when you think about whatever it is, do you want the ice cream dripping down? Because we've seen this time and time and time again with all these different hacks. We've got these people holding up their, ice cream hands, and we're like, oh, that won't happen to me. But then it happens to the next person and then the next person. So I'm sure that the CCSS was designed with, ice cream in mind. But I think it's a good reminder that you get kind of what you get if you're not being careful with what it is that all of your assets are sitting in.
That was
Your
incredible.
food analogies melt my heart.
Yes, fun.
I have to go eat an ice cream cone now after this, but
Same. So, okay, we've talked kind of around the standard and key management and smart contracts and all of these different threats. And I do think it's worth reading Dirk's article where he talks about this, and I put that in the chat. But also, the standard is free. It's out there. Anybody can read it and take a look. And you can also view if the system you're using is CCSS certified. Have they gone through an audit and an assessment, and can they prove that they're taking security safely? So Fireblocks has gone through an audit, Liminal, Tholos, all of these systems have been certified as level 3, and you can check that out on our website. If you want to learn more, you can also take our level 1 training course that walks you through all of these requirements, because if you're not a security focused person, you might read about entropy and be like, what am I actually looking for? So this walks you through some of the details of it. Also free hardware wallet course if you want to learn more there. And then what else do we want people to learn, or what are some of the other takeaways that are important?
Just to be clear, the article is free also. Yeah.
$5 million, yes.
No, and also the certified Bitcoin professional, right, and the certified Ethereum professional, right, are certifications offered by C4, but also there's a lot of training materials out there, and a lot of other live streams and free trainings, free video trainings and stuff as well out there from that.
You know what, this kind of goes back to what Michael was saying in terms of there being lots of like help guides now on different websites. And so I feel like with 10 years ago, maybe there was some small excuse to not have your security up to snuff. I don't know that there really was, but particularly now when we have all of these resources that are free and available, some of them are paid, but they're a lot cheaper than having to, reimburse your entire customer base through your insurance if you have it. Because you've lost it. But so there are all of these resources out there to prevent this from happening. And I think the question that at least I want to ask people is, are you using secure systems, and how do you even know if they are secure or not if they haven't been audited or assessed? Because we've seen time and time again these examples of, we think that this is safe and secure, we trust this, and then we're proven wrong over and over again. Any other closing remarks or things that you think people who are watching the stream should be aware of before we head out for the day?
I just wanted to talk about hamburgers for a quick moment.
Look, at the beginning of this live stream, it felt like we were throwing out risk after risk after risk. And if you're not really in this industry like we are, and you're hearing about all these dangers, it could probably leave you feeling a little bit apprehensive. And it's scary when you feel lost. But that's what the CCSS is. It is your map. It is your guide to let you understand what it is you need to do and what you should do next to improve security. The standard is all free, as Jessica mentioned, easy for you to look up and read on your own. But if you're not very technical, and you know that your system needs one of these types of audits, and you're not the best person to do it, there are CCSSAs, CCSS auditors who have gone through the standard with a fine-tooth comb, and took an exam and proved that they know the standard inside and out. These are the people that you want to either hire if you don't have someone yet, so that they can take an outside look at your system. Or if you have a security professional on your team who maybe comes from the Web 2 world and wants to test their mettle against this new Web 3 world, show them the CCSSA exam, show them that they can get a new credential, get some more letters after their name, and broaden their customer base. Now they'll be able to do a whole different type of cybersecurity to not only keep your project safe, but to help other projects as well. Every one of us that's on this call has contributed to this open source standard over the last, 8 years it's been alive, maybe 10. And there are many other people who aren't even on this call who contributed as well. So this sum of many people's knowledge is an invaluable tool to both measure and improve the security of your system.
Mm. And that goes, and I completely agree. And also too, with the auditors, the CCSS auditors, there's actually a group of auditors that work out how they can promote CCSS more, how they can improve the standard more, or the processes, or the auditing process, the certification process. And it's a very open community, and the ideas and the suggestions that the auditors provide the steering committee are always taken on board. And, if there's changes that need to be made, changes are done. So it's very community focused, the standard. It's coming from ISO 27001 and PCI DSS myself, I was quite amazed at how open the community is and how passionate they are in terms of contributing their own free time to make the standard better. I found that incredibly impressive.
Yeah, I think that the takeaway from all of this is we're all trying to work together to make the cryptocurrency and digital asset space safer. And so if you have feedback, join us. If you work somewhere where you know that the security isn't as high as it should be, don't just sit back and wait for the next FTX to happen. You're part of this community and your input is valuable, and you should be doing what is needed to make sure that other people's assets, not just your own, are secure and safe. And the tools exist now, so let's go out and use them. Thank you for joining the live stream, everyone on here. I feel like I always learn so much from you. And for those watching and listening, if you have questions, you can feel free to at us, and we will get back to you with it. So thank you all so much for spending your afternoon with us, or morning if you're Mark. We appreciate you all, and we will see you at the next live stream. So thank you. Take care.